All right, let's go ahead and get started. I thank those that have joined so far, and obviously, we're finding out in the new COVID world, a lot of people watch these things online. So I welcome those online as well that watch this through a recorded session. I'll get started by saying my name is Solomon Gifford. I work with a company called Contigix in their Black Mesh with the Black Mesh team, and we've been involved in the Drupal community for a really long time, over 10 years, doing Drupal hosting, doing managed services in the Drupal CMS WordPress space. And one of our primary areas is on security. And so this presentation today really focuses on SecDevOps and some of the security components of the software development lifecycle. And so with that, I'll go ahead and advance the slides here and we can get started. I kind of already said some of this, but just as a little bit of a background, you can contact me at the email listed or on Drupal Slack. I will try to appropriate. And the company that I'm with, like I said, has a lot of compliance that we do. That's the FedRAMP and other things. And some of the things that we've been doing lately is working in the SecDevOps, setting up workflows for customers. And we use GitLab a lot and another tool called Cascade. We won't be demoing Cascade today, but if you are interested in seeing more about some of the stuff we're doing, just please get in contact with us and we can go with there. But let's go ahead and set the stage for what we're talking about today. So there's a lot of compliance frameworks out there. FedRAMP is the biggest one of the biggest ones, I should say, in the federal space for hosting Drupal or WordPress or other types of sites. And these compliance frameworks historically have been focused on the production environment. So we're talking about vulnerability scanning and network intrusion, malware protection. I won't read the list, but the point is that the production environment has been the focus. However, what we're finding is that the production environments are decently secure. And so attackers are shifting left. They're focusing on the supply chain, which is really our conversations for today. I have a definition there you can read on your own. But the takeaway is that a chain is only as strong as its weakest link. And hackers know that. Attackers know that. And so they have been focused on shifting left. And what I mean by that is going to the dev environment, going to the build environment, potentially even attacking developers, local development environments. So we have to start thinking about shifting our security left at the same time. I like talking about two examples, Keseya and Solarwinds. They're really high profile, have happened within the past year. And by the way, there's a number of others even this year or before this year. This is not a new problem, but it's much more visible now. But let's talk about the Cassette Attack first. So Keseya is a remote monitoring and management software, and it had update servers that were internet exposed. And what I mean by that is they were available publicly on the internet, and there was a 0-day vulnerability, and hackers were able to use that vulnerability to log into the update servers, upload a malicious update, and immediately, or I should say within 5 minutes, 1 million end clients had received that ransomware attack via auto updates. And auto updates is something that the security community has been preaching for a long time, right? Have them turned on. But the problem is that, okay, now that is an attack vector. How can we secure ourselves against that? And so, again, shifting left, that's the point. The SolarWinds was similar in the sense that it went upstream. SolarWinds they also had a network management software, and their build environment was compromised. So an attacker was able to log into the build environment and upload a compromised DLL. The auto updates that customers had on downloaded those updates, and it actually waited 15 days in order to strike. And what I mean by that is it laid dormant, and by laying dormant, different security software did not see that there was an issue with that new, new executable. And so after that period of time, it reached out to the the hacker's infrastructure to get commands, and at that point was able um, to start the attack, and the hacker was able to get remote access to 18,000 customers. So in both of these situations, the attackers hit left; they went left in the process, and so this gives us a an incentive to also secure to the left of the production environment. Um, President Biden in May put out a executive order that aligns a number of things that need to be done, and the security community is essentially responding to that. But it's not just the executive order. This is something that's been going on for a while. It just has a lot more visibility. To kind of give the design principles that we need to focus on, there's a primarily four. First is the concept of least privilege. If a person has access to everything, including your build environment, including the production environment, including the dev environment, then you're quite exposed if that person is compromised. So the concept of least privilege says that we only want to give access to those that need that access to accomplish that job and no more. Immutability is the concept that, to the right of your dev environment, we do not want changes being made. Everything should be automated, and if possible, with along with the next bullet, it shouldn't be changed and it should be redeployed. The concept of everything is code really says that we're not sitting out there on infrastructure that could potentially be compromised, and we're redeploying to that compromised infrastructure. Instead, we're using code to deploy that, and we can continue to deploy that repeatedly. And it also means that we can have an audit log of that of those changes, which is where traceability comes in, the last one here. And it really says there that we can see what happened. Um, we have version control on the changes, and then also logging. So a little hint here is that we're not really trying to achieve security. It's an unattainable goal. What we're doing is essentially putting in risk management or governance so that we can increase our security, and then compliance comes behind us, and that is what we use to check the boxes and say, hey, we're doing what we're saying we're doing. So these design principles give us kind of the stage for some recommendations. When we talk about least privilege, we are talking about separation of duties. People doing deploys to production shouldn't be the same people with access to your build environment or to your dev environment. When we talk about traceability, we're also talking about logging so that we know who did what, when did it, and what happened. It allows you to reconstruct events and know how, um, what the extent of some attack could have been. And then when we talk about immutability, it also lends itself to separating environments. We want a separate environment for production at a minimum, but more, even more secure would be a production environment that changes every time that it is you need to go live again. You're essentially deploying the entire infrastructure with your code changes. And with that, you're implying data separation. If you're redeploying your code but not your database, then those need to be separated. So a lot of the different compliance frameworks focus on traceability, least privilege, and immutability as high-level concepts, and a lot of the components of those compliance frameworks fit up underneath that. So as I'm going to give a bunch of recommendations today. Some of them, or a lot of them, I should say, are related to Drupal. And what I'd like to start out by saying is that don't get overwhelmed. There's a lot here. If you've never done any of this before, you could essentially throw up your hands really quickly. And that's where the second bullet here talks about incremental change. Start small and focus on continual improvement. And with that mentality, any net change that you make that makes things better is a step in the right direction. And really what we're doing from a conceptual perspective is shifting left. As the attackers are shifting left, we also are shifting left. And what that means is that developers, unfortunately, are now responsible for security. We're not just passing that off to the security team. Instead, we as developers have to be part of the process. And that whether that's updating dependencies, we'll talk about that, whether that's making sure that we are running scans against our code, whether that means that we are solving vulnerabilities earlier in the process, those things become part of our responsibility. But we also get that feedback loop earlier, and that's part of the value. And some of the things that help us with this is automation. I can't stress this enough. You don't want to be running manual tests and scanning and monitoring every single time you do a deploy. You want that to be automated. But what that also does is it removes process backdoors. What I mean by that is if you have a system that you even yourself don't have access to do a manual deployment or to do a manual build, it's all automated, then that means that an attacker is going to have that much of a more difficult time making changes. Also, there's a lower barrier to entry. Yes, there's a lot of investment to set up an automation, but that means that the net new person being added to the project doesn't have to setting all of that up. It's not all manual processes that they have to own and worry about. Instead, they can jump in much quicker and get started with development because it's all been set up. Yes, there's that initial investment, but each net new person doesn't have to do all of the extra work to set everything up. And it gives us that built-in governance, right? That governance, what I mean by that from that previous slide, is the concept of risk management. So I put this together as 5 steps to DevSecOps maturity. Some people might disagree with my 5 steps or 5 levels, if you will. These are my take on. And this really, where this comes from is how easy has this been for us to set this up ourselves. And so that's where I've created the categories. And so as we go through the rest of the presentation, I'll focus on each of these as essentially in buckets. But there's also some common themes within them. And one thing I do want to mention is that I'm assuming that we're automating this in process. I don't have automation as a step. But really what I'm saying is as we do each of these, we want to start focusing on automation. So if we want to talk about the first level, the first of those 5 layers of SecDevOps process, the first one we're going to talk about is securing the environment. Thinking back to in the Solarwinds attack, because the environment itself was insecure, that was the first way that the attacker could gain entry. And so what we want to start thinking about is the authorization boundary. Now, for those of you that work with FSMA or FedRAMP, you understand the concept of an authorization boundary. But think of an authorization boundary as really, if I were to take a production environment, and we'll use production for an initial example. If I was to take a production environment and take all the servers or all of the infrastructure or all the networking, and I were to draw a line around that, and then I were to think about what data is going that circle and what data is coming out of that circle, if you will, authorization boundary. It's essentially inside of that is my authorized system, outside of that is my unauthorized system. And what we want to be thinking about is the data that's flowing in and out of that system. So historically, with FedRAMP and other programs, the real focus has been on production. That's the green area of this process here that's circled in the bottom right-hand corner of my slide. But the bigger picture is, can we extend that authorization boundary? Can we actually make the process, can we apply the same controls that we would have done to a production environment? Can we apply those same to the dev environment, to the build environment, or even to your laptops? And so that's the first thing to start thinking about, is what data is going in, what data is going out, and the larger we can make that authorization boundary, then we're inheriting the already has. So let's be real, give a real example here. Let's say you have a FedRAMP environment, that's where you put your production, and then you have a dev environment that's outside of that. Well, when you take your code live by putting it into from where it is in the build environment and take that live into the production environment, you're actually taking insecure code and bringing it into the FedRAMP boundary. However, if that build already been inside the boundary, then there's not a risk going from that build environment to production, because there's less likelihood that an attacker would have been able to get access to that build environment. So that's the first step. And many times you're going to be working with a CSP, a cloud service provider, and this is kind of, and that's why I call this like the lowest step, is that essentially your cloud service provider can just provision additional infrastructure for your staging or for your dev environments, for your build environments, and then you make sure you do your work inside of those environments. And this would have addressed the SolarWinds attack to some extent, in the sense that we're applying the same controls that we usually apply to a production environment to a build environment. I will point that FedRAMP doesn't currently require that. However, the Biden-May 2021 executive order talks a significant amount about securing the software development process. And so I expect to see this concept of an authorization boundary widening over time to include some of these other steps. All right, so step one, level one unlocked, level two. We could talk about code scanning and artifacts. So a couple things here. SAST is this concept of static application security testing. This is scans that run against your actual code. So whether it's JavaScript, whether it's PHP, you're actually running a scan against that. And it's looking for common patterns that are known to be insecure. For example, going off the end of an array or something like that. So we want to run static analysis against our code. Code quality. There are pieces of software out there that do code quality testing, and it is well known that the higher quality your code is, the more likely it is secure. If you're taking shortcuts with your code, then you're probably taking insecure shortcuts, or maybe not you, maybe somebody else on the team. Secret detection. Don't want passwords inside of your code. Dependency scanning. That's talking about the upstream packages that you are inheriting. And we'll talk about more of that as we go on, because that's really core to this presentation. But when we talk about that scanning, that just gives you a list of which packages have available security updates, and you want to make sure that you can run those. And then when we talk about container scanning, there's best practices for containers, and we want to run scanning against those containers to make sure they've been built securely as well. So I have actually some recommendations here. I'm going to go quick through this. I will make these slides available so you can come back and dig into these more by clicking the links, etc. But essentially, when we talk about automation, let's put some automation around pull and merge requests so that we can run SAST every time. Essentially, we want to catch these issues early when it comes to the code quality, when it comes to SAST. It lowers your cost to remediate errors. If you can fix those right at the time of development, you can do that before you do your merge, before you do your integration, before you take it to production. The earlier you can do those corrections, those remediations, then the lower cost it's going to be in the long run. You really don't want to do this on every commit. I said that a second ago, but you really don't want to do this on every commit. You really want to do it on your primary branches only, because there's a lot of false positives, and you don't want to wade through each of those every single time and slow down development. There's a solution list there on OWASP.org, and one of the things that they recommend I have on the right hand of the slide here, which is PHP Code Sniffer. It's an open source project, and it is also what GitLab uses. You also want to do secret detection, and I've given a couple of resources there, and that is also available in GitLab. GitHub also has some use of Trufflehog, if I'm right. When we talk about Drupal dependency checks, there's a couple of resources there for PHP, NPM, and Yarn. GitHub has a free action. GitLab Ultimate has whole dependency scanning built in for a number of languages. But I will put here as a note, make sure you still are reviewing your changes before they go to production. And I'll come back to that a little bit later. So the things that we've talked about so far, including this one here on scanning, these are all happening very early in the process. These are things that developers are doing as they are developing. You want to start with hardened images if you're doing container development. There's a bunch of free ones from Platform One. There's some other ones out there as well if you don't want to build your own. But you want to first use hardened images and then you want to scan them. There's a number of free scanners out there. There's also some paid for scanners. GitHub Actions does have a solution there, and GitLab uses Gripe or Claire, and that's done. Gripe is the open source project for a container scanning technology by a company called Encore. So there's a number of free container scanning options, and of course there's paid options as well. But that's this. Let's get you started. All right, so we've unlocked the concept of the static analysis. Now we want to actually scan a running version of our application, and so this is where DAST testing and fuzz testing comes into play. DAST is the idea that we're doing black box testing. We're performing an actual attack, and the software is actually trying to attack your code. And this is language agnostic, right? It's attacking a running binary. It's the running version. And of course, you want to automate this process. You don't want to be running this manually. You never should scan in production. This is an actual attack because it will attempt to cause damage. But it should be in a production-like environment. More appropriate would be like a QA environment or a pre-production environment, where if it's compromised by the software, it doesn't impact production, but you can get a realistic feel for what the attack could uncover. Zed Attack Proxy is a good example. There's other ones there at the link. When we talk about fuzz testing, we generate random input. This is great for finding things like on form inputs, for example, not having good error checking. And so system crashes or failures that could potentially happen, buffer overruns, et cetera, could be found and compromise the application. So this is one of the ways that attackers actually attack your application. They do their own fuzz testing, see if they can compromise your application, and if they can, they try to repeat it. So both of these are, using known attacks or just generated random input are both good tests to run against a running environment. All right, so step 3 unlocked. Time to go to step 4. I want to talk about securing the supply chain. And this is really, kind of the title of this presentation. All of what we're talking about helps us our supply chain, but there's some more specific things we want to think about when it comes to Drupal and updates, for example. So these updates could come from a number of sources. It could be a new dependency that you're adding. It could be an update to one of your dependencies. When I'm talking about dependencies, I'm talking about your Composer or NPM modules that you're including. Or it could be upstream changes, right? If Drupal core is updated and you need to make, to upgrade to the latest point release. So a lot of times people like to automate these processes, and automation is good. So I'm not taking away from the automatic process. However, you shouldn't have a build process that automatically immediately takes those changes into production. Both the Solarwinds and the Keseya attacks showed us that we really need to have a human review of that process before it goes into production. So when it comes to critical updates, obviously you want to take those live as soon as possible in most situations. However, let's assume for a second that critical update was actually a hacker. Well, in that scenario, you want to have an opportunity to review that update and make sure that that's not introducing something that actually is a vulnerability. And then for non-critical updates, my recommendation is to put some time, some delay between when that is discovered or when that is released as an update and when you take it live. We found with the Solarwinds attack a delay of 14 days. That was the patience that they had. During those 14 days, 14 or 15 days, I forget which. But during that time, the security professionals could have found that issue, right? The longer the time, the more likely a security professional will find the vulnerability. And you want to essentially not be the first guy out who is compromised. So let's imagine a scenario where a compromise in the upstream happens. Everybody deploys it, but you don't. Everybody gets compromised, but you don't. That's the scenario you want to be in. So I am not trying to downplay the need to push security updates to production. They absolutely do need to be pushed to production. If you can't auto review it and it's not a critical, then consider putting some time. And that time is really up to your organization's policies. To help with this, consider using a thin repository for your development and a thick repository for the artifacts. And what I really mean by that is you on your laptop or on your desktop or wherever you're doing development, you don't want to have every single library's source code in that repository. Instead, you just want to be developing with the code that you might be changing. And that is good programming practice. We call that a thin repository. You're going to use Composer or use other build packaging systems to pull in other components. However, we still want to have a process where we can see what changes are being made to what is actually taken live. And so what we recommend is take the output of Composer and NPM, put that into a thick repo, and that allows you to have a step of reviewing before production. And I have a couple more hints about this as we go forward on other slides, but we really want to have an opportunity to see what changes are being made to the production environment. And if you are just depending on your dependencies, they are dependencies after all. If you're just depending on them without doing any type of review or any type of waiting, then you are putting yourself at risk. Okay, some other policies that are really important. First of all, you want pull requests to always require at least 2 reviewers. Let's say that an account is right. Well, and a hacker could essentially upload a code change in the name of another person. As long as there's a code review, then there's a second person that attacker would also have to compromise in order to approve that pull request. So having a buddy system, if you will, requires multiple vulnerable accounts. For those that are advanced, you should only allow or accept commits from developers that have signed that code commit with a GPT key, and that protects against, again, an unidentified source making a commit. Obviously, if the developer themselves is compromised, that's not going to help you, but you do want to start with that signature early in the process. And that actually goes along with the last bullet here, which is you want to sign and validate artifacts along the way, along the build pipeline. If you're not familiar with signing and artifact signing and all of that, then we're not going to go any more in this presentation. But it's definitely a level 4 exercise, if you will, to make sure that the code that you are committing is identifiable. When you get to the final product, the final application, you can see all the different code components, and you can track each commit back to an author. And so there's a traceable human behind each line of code or each change, and that's what you want from the perspective of traceability. Remember, that was one of our design principles that we started with. Only accept dependencies from trusted registries. I can't stress this one enough. If you find some package on the internet, you start including it, that's going to be insecure for multiple reasons. So you want to find registries that you trust. And when you evaluate them, look for ones that have multiple maintainers. Think about that same scenario that we talked about earlier. If a single developer can be compromised and introduce a threat or a vulnerability, then so could also an upstream be compromised by a single person. So you want to trust repositories that have policies that require um, multiple reviews on commits. And so essentially look for multiple maintainers. Look for registries that require multiple review processes, or if you're just pulling a package from a trusted repository, make sure that package uses multiple reviews. If you find some package, even on a trusted repository, that's only maintained by one person, or just one or two very inactive people, be very careful, because in those situations, I've seen times where um, those maintainers will just accept anything that is requested as a merge request, and essentially they're too busy, they're doing other things, and so it's not an active community. So be careful with those types of situations. So kind of have, within the organization, set some standards. You're not going to use a package unless it has a certain number of maintainers and a healthy, active, supported group. If you don't, and you decide to accept it anyway, turn off those automated updates and instead use the process of reviewing those changes yourself. Take on that responsibility yourself of reviewing any upstream changes. And that does not mean to leave changes out for a long time. Again, going back to this previous slide, you still want to um, review critical automated updates, even from those little packages. But we don't want to essentially take the second bullet here, where we just do time. We still want to add the review as well. For container images, set a standard. And actually, this is for your code too, for your SaaS, et cetera, as well. Set code standards where you're not going to accept, for example, any critical or high vulnerabilities. This is especially important with containers, but it's also important with um, with SAST or DAST or fuzz testing and the other ones. Set minimum standards. And if you find yourself in a situation where you're extremely insecure at first and you want to make slow, continual change, then you have that opportunity to set standards first and then to increase them over time. And that's definitely how I suggest, making change over time. I recommend, if you want to get deeper into this, I recommend reading this GitHub project. Has a blueprint for a secure software pipeline. It also has a bunch of controls that are related and really capture a lot of the things we've talked about today, or not all of them, but a lot of them. And it's a great place to start to understand some of the reasoning behind some of the arguments and suggestions that we're making today. I won't go a lot into this level 6, if you will, the advanced interactive protection. But I will say that SAST and DAST focus on static or dynamic application security testing. There's a whole other layer that I have not even gotten into myself, but it's called interactive application security testing. And what that really does is it looks at the code while the software is running. Think APM for security. There's an agent that is looking at that in real time at the operating of the application. And if it is noticing things happening within the application that are suspicious, then it throws alerts and allows you to intervene. So I want to, before I open it up for questions, I do want to give an opportunity to show a little bit of a demo of some of the stuff that of how we've implemented this, because I know that demos really show a whole lot more and make it real. And so this is actually our live instance. Hopefully this worked. You know how demos go. So this is a repository of a Drupal project. And I don't know if this is Drupal 9 or Drupal 8, but it's a Drupal project. And you can see this is GitLab, which is what we currently use and our customers also use. And by the way, if you need help getting this set up, please reach out. This is some of the stuff that we enjoy doing and setting up for customers. But you can see that I made a change here 5 hours ago. I updated the README just so that we can see a change being pushed through. And then if I go over to my CI/CD, then I can see that for each one of these, I have a pipeline. And when I look at the pipeline, I can actually watch it run. And before I go to that pipeline and see how it ran, I will show you that the pipeline is essentially built by, at least in GitLab, by using this CI, GitLab CI file, and it defines all the different phases. And what's really cool about GitLab is it has a lot of this stuff that we talked about today built in. Some of it's in the free version, some of it's in the enterprise version. But regardless, you can either set it up yourself or you could use GitLab's pipeline. Again, you can use other pipelines as well. This is just what we use. And here's your pipeline. So when we talk about the pipeline, I can see this pipeline passed. I can go and I can see that here are all the tests that were run. So it builds the project, that's the build stage, and then it runs all of these different tests. Some of them are SAS testing, some of them are dependency testing, some of them are secret detection, etc. And then it goes to a dash stage. We also do what we call a review stage, where it allows us to build the actual application in a container, and so we can actually click on a link and view the running application and see that application and run manual tests if we want to against it, or just do that for not necessarily security testing, but just for acceptance testing. Maybe not accepting testing, but some form of acceptance testing. Okay, so then I can actually click into these and see what actually was run. I won't dig into this too much, but I will show you that once you have done that, you actually see all of the security issues in a dashboard. And so this dashboard shows you that we set this project up, back here earlier this year. And as we added new security things, our number of issues increased. However, just having a graph isn't enough. Let's go actually dig down into the report. This, by the way, is a Drupal project. Almost 4,000 issues just from the default scans, whether it's the fuzz testing, whether it's the dash. Between all the different types of testing, there are over 400 issues. And we can actually now filter by each one. So let's focus on just SAS. So let's assume that you are part of the SAS process. Here you go. So all of these are issues that probably should be looked at. And if you decide that this is something that you need to address, you can select it and set its status to needs triage, or you can dismiss it. You can accept the risk. So that's the whole concept of vulnerability management. And then, of course, you can run on-demand scans as well. For each one of those vulnerabilities, you can click in further and actually see the CVE and click out to more links, etc. And it'll show you what to do there, or at least give you some hints. Finally, it does show dependency list. These are all of the upstream dependencies and vulnerabilities that they have that you may want to remediate. So that's a very quick demo. I hope this presentation has been helpful. Please, if you have questions, put that into the Q&A. Feel free to add those to the chat, and I will stick around here and try to answer some questions. So we can get started with Q&A, but definitely appreciate your time today, and thank you so much for joining this presentation. Yes, it is very much an incremental process, not going to just start small and continually iterate over time, or work with a partner that can help you accelerate. But yes, you're welcome, Gabriel.